Welcome back to the channel. In this video we'll look at the solutions to question 5 and 6 in the combustion and thermal decomposition series. So let's get started. So here's question 5. When 3 moles of benzene are combusted in excess oxygen, what mass of gas is produced? So as before, first of all we'll write down the structure of benzene. There it is there, the benzene ring. And the molecular formula of benzene is C6H6. So now we need to write the combustion equation, and so there we have the equation, and we need to balance it. So on the left hand side there we've got 6 carbon atoms, so we need 6 carbon atoms on the right. If we put a 6 in front of the CO2, then we get 6 carbon atoms. Looking at the hydrogen, we've got 6 hydrogen atoms on the left. To get 6 hydrogen atoms on the right, we need to put a 3 in front of the H2O. 3 times 2 is 6 for the hydrogen. Now let's look at the oxygen. On the right hand side, we've got 12 in total from the 6 CO2 and another 3 from the 3 H2O. 12 plus 3 is 15, so we need 15 oxygen atoms on the left, and to get that we need to put a 7.5 in front of the O2, since 7.5 times 2 is 15. So now we know that if we can bust 1 mole of benzene, C6H6, we get 6 moles of CO2 and 3 moles of H2O, steam. So the first thing to do is to work out the mass of 6 CO2 and 3 H2O. So let's do that. So first of all we'll start by finding the molar mass of CO2, and it will be 12, the atomic mass of carbon, plus 2 times 16, 16 the atomic mass of oxygen, and if we add that up we get 44 grams. But we got 6 moles there, 6 CO2, so we've got to multiply the 6 by 44, giving us 264 grams there. Now let's deal with the steam. So the molar mass of H2O is going to be 2 times 1, 1 being the atomic mass of hydrogen, plus 16 the atomic mass of oxygen. Adding those together we get 18 grams. But in the equation we see we've got 3 moles of H2O, so we need to multiply the 18 by 3, and that gives us 54 grams. So therefore the total mass of gas that we get there is 264 plus 54, which is 318 grams. And that will be when we combust 1 mole of benzene, as we see from the equation. But the question says we've got 3 moles of benzene. So clearly we've got to multiply that figure by 3, giving us 954. Answer C. Let's go on to question 6. What mass of ethane diol will fully combust to give a total of 497 grams of gas? So we write down the structure of ethane diol. There it is. And when we combust that with oxygen, assuming we've got enough oxygen, we're going to get again carbon dioxide and steam. And so we must balance that equation. On the left hand side we've got 2 carbon atoms, so we need 2 in front of the CO2 on the right hand side to get 2 carbon atoms there. Looking at the hydrogen now, on the left hand side we've got 2, 3, 5, 6 hydrogens, so we need 6 hydrogens on the right, and to achieve that we need to put a 3 in front of the H2O, so we've got 6 hydrogen atoms there as well. Now let's look at the oxygen. On the right hand side we've got 2 times 2, 4 from the CO2 and another 3 from the H2O. 4 plus 3 is 7. On the left hand side we've got 2 oxygen atoms in the ethane diol, So we're going to need another 5 in the O2. So we need 2.5 in front of the O2 because 2.5 times 2 is 5. So now we've got a balanced equation, and from it we learn that combusting 1 mole of ethane diol will give us 2 moles of CO2 and 3 moles of H2O, steam. So, as with the last question, we need to work out the mass of that 2 CO2 and 3 H2O. So let's do that. First of all, the molecular mass of CO2 is going to be 12, the atomic mass of carbon, plus 2 times 16, 16 the atomic mass of oxygen. Adding the figures together, again we get 44 grams. But from the equation, we've got 2 moles of CO2, so we need to multiply the 44 by 2, giving us 88 grams. Turning to the steam, H2O, so the molar mass of H2O is 2 times 1, the atomic mass of hydrogen, plus 16, the atomic mass of oxygen. Adding up, we get 18 grams. And we've got 3 moles of H2O there in the equation, 3 moles of steam, so we multiply the 18 by 3, giving us 54 grams. So the total mass of gas there is 88 plus 54, 142 grams. Now that 142 grams of gas is what we get if we combust 1 mole of ethane diol. But we get 497 grams of gas. So we've got to work out how much larger 497 grams is than the 142 grams that we got here. So to do that, simply divide 142 by 142 to get 1. So 1 gram of gas results from the combustion of 1 divided by 142 moles of ethane diol. And now we multiply by 497 to get to 497 grams. So clearly we've got to multiply this fraction on the right by 497 as well. And that gives us 3.5 moles. So that's the number of moles of ethane diol that we must start with to get 497 grams of gas when we combust it. But we've got to convert that to mass. So first of all, we need to work out the molar mass of ethane diol. The molecular formula there is C2H6O2. So if we do that, 2 times 12, 12 the atomic mass of carbon, and now add on 6 times 1, 1 the atomic mass of hydrogen, and 2 times 16, 16 the atomic mass of oxygen. Adding those figures together, we get 62 grams. We found out that we need 3.5 moles of ethane diol, so clearly we need to multiply the 62 by 3.5, and when we do that we get 217 grams, and that corresponds to answer C above. So those are the solutions to question 5 and 6. Once again, I hope you found this helpful, and I look forward to seeing you in the next video. Thank you for watching.